So today we're going to solve systems of equations. Now don't worry, a system of equations just means that you have more than one equation. So a system can be 2 or 3 or even 4. It's usually just 2 though. So we're going to solve it by graphing. So given two equations, graph to find the intersection, and then the intersection is your solution to your equations. So I have these two equations, y equals x plus 2 and y equals negative 2x plus 1. So I'm gonna plot the intercept of this one. So positive 2 right there. And then I'm gonna use my slope to find my line. I'm gonna go up 1, over 1, up 1, over 1, down 1, over 1, down 1, over 1, down 1, over 1, down 1. And I think that gives you a pretty good idea of your line. So then we're going to draw our line, and there's our line. So now we have the equation y equals negative 2x plus 1. So we're going to start with our intercept, and I'm going to graph this in a different color so we can see the difference. So we're going to start with our intercept of 1 and go up 2 over 1, up 2 over 1, down 2 over 1, down 2 over 1, and we're gonna and you'll see that that is approximately negative 1, 1. And like I said, it'll be easier to see on graph paper where you have exact scales and everything. So our solution for this point is negative 1, 1. So now we're going to talk about another way to solve systems of equations. We're going to do it by a method called substitution. And when you substitute a variable, what you do is you want one of the equations to be written as either y equals or x equals. And then you're going to substitute that equation into the other equation. So they're both already solved for y, but I'm going to substitute this one into this equation. So if I substitute x plus 1 for y into this equation, I'm going to get x plus 1 is equal to 3x minus 3. If I bring the x over, I get 1 equals 2x minus 3. If I add the 3 over, I get 2x equals 4, and x equals 2. But you have to make sure that you keep going until you get an ordered pair. So now we have to plug this x value into either one of these equations. It really doesn't matter, but I'm going to do this one just because it's easier to find what y equals. So y is equal to x plus 1. So y is equal to 3. So our solution for this system of equations is 2, 3. So we're going to do another substitution problem that's a little different. So these two are in standard form. So in order to do substitution, we need to solve one of these equations for a variable. So I'm just going to pick this one. No reason. You can do it for either one. It doesn't matter. And I'm going to solve for y. So if I'm going to solve for y, I want to get y by itself. So to do that, I'm going to subtract the 2x over to the other side. So I'm going to get negative 3y equals negative 13 minus 2x. Now I'm going to divide everything by negative 3, and I'm going to get y is equal to 13 thirds plus 2x over 3. And these change signs because when you have a negative divided by a negative, the whole thing becomes positive. So both of these become positive. So now that I have this solved for a variable, I'm going to plug this into this equation for y. So I'm going to have 2x plus 5, 13 plus 3, there should be an x, or no there shouldn't, 13 plus 3 plus 2x over 3 equals 27. So I'm gonna distribute this 5, and I'm gonna get, so if I multiply 13 times 5, I'm gonna get 65 over 3 plus 5 times 2 is 10x divided by 3 equals 27. So I'm going to collect like terms, which means that I'm going to add this to this and this to this, and I'm going to get, okay, so in order to do this, I need to get a common denominator for all of them. So I'm going to make them all have a common denominator of 3. So if I make them all over 3, I have to multiply 2 by 3, so I get 6x plus, this is already over 3, this is already over 3, and 27 times 3 is 81. So now I'm going to combine my like terms, and so I'm going to add my 6x over 3 plus 10x over 3, and get 16x over 3, and I'm going to subtract this side over, so 81 minus 60 gives me 16 over 3. If I multiply both sides by 3 to solve for x, I'm going to get 16x equals 16, get x equals 1. So we're going to plug 1 back into one of these equations and to solve for y. So I'm going to plug 1 into the equation that's already solved for y. So y is equal to 13 over 3 plus 2 times 1 over 3. So y is equal to 13 over 3 plus 2 over 3, which gives me 15 over 3, or 5. So our solution for this problem is 1, 5. So that's all we're going to do for today, but make sure you come back and watch the next lesson where we're going to talk about 2 other ways to solve systems of equations.